Let's take a look at another example to illustrate how the selection of appropriate representations could facilitate finding solutions to more complex problems. Similar to tic-tac-toe, the problem here starts with a 3x3 grid, but in this problem, the cells are occupied by square apples. Let's call this the square apple problem. Do you know that people can actually grow square apples or even square watermelons? They are very expensive though. Don't worry, even if you have not seen or eaten a square apple before, you should still be able to solve this problem. Consider that in the initial stage of this problem, there's a worm in the middle cell. The question is whether it's possible for the worm to eat through all the apples by following these two rules. The first is that after the worm finishes the whole apple in the current cell, it can only move to another cell that shares a common side. So these arrows show the 4 possible moves. And the second rule is that it cannot move to another cell that has been visited before. That is, the worm can only move into a cell where there is still an uneaten apple inside. In this graph, it shows that the worm starts from the middle. After it finishes the middle apple, it can move to one of the 4 cells on the side, but not the ones in the corner. So the worm can move to the right, move down, move left, and move up. I want you to take a minute to think whether there's a solution to this problem. That is, whether the worm can eat through all the 9 apples. This should be quite obvious. So here is part of the state space graph. If you explore further, and this is a possible path that could lead to a solution. In fact, you'll find that there are 7 other solution paths by trying out all the other moves. I want to show you a Java program that was written to solve this problem. By the end of this course, you should be able to write your own program to solve problems like this. This is a demo program that we have written for you to illustrate solutions to the 3x3 square apple problem. The problem will start with a worm in the middle. The worm visits the apples by moving to another cell that shares a side, while not revisiting any cell that have been visited before. The numbers shows the sequence of steps. The program also displays the sequence of steps in another window. So you can see that there is a total of 8 solutions, as discussed before. At the end of this course, you should be able to write your own programs to solve problems like this. Let's now take a look at the 3D version of this problem. The problem is basically the same as before, except that you have a 3x3x3 cube, like the Rubik cube, and with a square apple in each slot. That is, there is a total of 27 apples. To help visualize this problem, the diagram here displays the cube in 3 layers. Similar to what we had before, there's a worm hiding in the middle. And we have to follow the same rules. That is, at the beginning, there are 6 possible moves instead of just 4 as in the 2-dimensional case. Because in addition to the 4 cells on the side in the middle layer, it could also move to the middle cell in the front and the middle cell in the back layer. And the question now is whether the worm could still eat through all the 27 apples. Remember that the worm cannot revisit any cells that have been visited before. Let's now go back to take a look at the two-dimensional problem a little differently. Instead of having all red apples, some of them are replaced by green apples, and they are arranged according to this diagram. If the worm were to start from the middle again, following the same rules, this is basically the same problem as before, irrespective of the color of the apples. Although I don't know whether the worm is colorblind, it should be easy to see that we have the same 8 solutions as in the previous two-dimensional case. Now, consider that instead of starting from the middle, the worm starts from one of the cells on the side, and with all the other rules remaining the same. I want you to take a minute to think again whether there is a solution to this version of the problem. If you don't have a solution yet, you should think out of the box. One hint is to consider how the color changes when the worm moves from one apple to another. Let's now go back to the 3D square apple problem and alternate the colors of the apples like what we have done before in the two-dimensional case. Like in the previous 3D case, the worm is hiding in the middle. So this is still the same three-dimensional problem as before, although the color of some of the apples have been changed. Now, use what you have observed from the two-dimensional case and try to come up with a quick solution to this problem.